So class, now let us learn about adjoint of a matrix. So if you are given a matrix A of order 3 by 3 and to find the adjoint, you simply need to find the cofactors. Cofactors represented by capital letters like A11, A12, etc. And we arrange the cofactors correspondingly as in the given matrix and take the transpose of that. So here you are given a matrix with entries 1, 3, 3, 1, 4, 3, 1, 3, 4. Now, first of all, we start with the entries in the first row. So you have there the entries 1, 3, 3. So let us find the cofactors of 1, 3, 3. Now the cofactor of 1 is written as capital A with suffixes 1, 1. And as you know, to find a cofactor, always you have to put -1 and then raise that to the power 1 plus 1, where 1 plus 1 shows that you are finding the cofactor of an entry which is in the first row and in the first column, and multiply that by the minor of A11. That means the minor of that entry which is in the first row and in the first column. So when you do that, you will be getting -1 raised to the power 2, and the minor of that entry which is in the first row and in the first column, it is 4, 3, 3, 4. That is written in the determinant of order 2. Now you continue to do the same thing to an entry which is in the first row in the second column. You do the same thing and you'll be getting -1 as the cofactor of 3, an entry which is in the first row in the second column. So you continue to do that to the entry which is in the first row and in the third column. So you will be getting -1. So that is how we find out the cofactors of those entries in the first row. Right, now let us find out the cofactors of the entries which are in the second row from the given matrix. The entries are 1, 4, and 3. Now I'll show you how to find out the cofactor of that entry which is in the second row and in the third column. In this case it is 3. Now to find out the cofactor of 3, so we simply write the capital letter A with suffixes 2, 3. Now that you can find out by simply writing -1 on the other side of the equal sign and raise -1 to the power 2 plus 3. 2 plus 3 because you are finding the cofactor of that entry which is in the second row and in the third column. Now you multiply that by the minor of that entry. So minor of 23 or M23. Now when you do that, you'll be getting -1 raised to the power 5 in the next line. And now imagine that you are deleting all those entries which are in the second row and in the third column. So when you do that, you will be left with 1, 3, 1, 3. Now write that in the form of our determinants of order 2. So simply that, and you'll be getting 0. Now you do the same thing to find out the cofactor of those entries which are in the second row first column and in the second row second column in the same way. And I would like you to try to find out the others too in the third row. So here on the screen I have shown you how to find out the cofactors of the entries given in the last row from the given matrix. So I will not explain here, but make sure that you understand whatever that you have seen there on the screen. So now in the next line, let us see how to get the adjoint of the given matrix. Now the adjoint of the given matrix A is actually the transpose of the matrix of all those cofactors. So the cofactors A11, A12, A13, and so on. So there you put the values of those. So you have the 7, minus 1, minus 1, minus 3, 1, 0, minus 3, 0, 1, and the transpose of that matrix I mean. So you will have 7 minus 1 minus 1 in the first row, but now you'll write it in the first column. 7 minus 1 minus 1, and the same you do to the second row and the third row. So that is the adjoint.